adjust the scenery. Cool. Alright, welcome back again. Another week. Some more hacking. Hopefully the audio mix is a little better on this. Let me know if you need me to tweak something here. Fortunately, I don't have any kind of like live monitoring for the audio setup, so I rely on the chat. On you agents out there. What are we going to work on today? Well, last week I had a little fun. We just did a little bit of lean, some formal verification type stuff. It was fun. Now it's time to get back down to business. Got a database to write to finish up. And it's been a while since we worked on Rosby together. So, just as a little refresher, we're in the middle of implementing a B+Tree, B+Tree technically, but we're going to try and do a B+Tree first and then try to do the plus part of it as the index for our database. The index being on top of the storage layer and kind of the way that you query for keys. Initially, we're just going to have like the usual kind of like hash map style operations, get a key, set a key, delete a key. But B+Tree would enable us to do range queries as well if we wanted to, or do more kind of like efficient loading from the storage engine. Like loading and caching and stuff if we want to go down that route. But this is a learning project, so I'm more interested in just doing the storage part. I kind of want to see what it's like what options we have in Haskell land for working with large volumes of data in memory, in working memory, without hitting that out of memory killer. Hopefully, we can do some stuff off heap or in heap. I don't know. So we're gonna figure that out. To kind of kick the tires and stuff. But to implement the B+Tree in Haskell in a pure functional way, taking different approaches, learning quite a lot about that. And the approach I'm currently working on right now is using a zipper, because the way B+Trees, as I mentioned several times over the course of doing these streams, B+Trees, they build from the bottom up, from the leaves to the top, which is not an unusual pattern for Haskell. It's kind of an odd way of doing things, and so zippers are kind of a way we're going to try this. And a bunch of streams ago, I think late November or early December, we did a whole episode on just zippers. So going back to that, a faithful YouTube follower pointed it out that our current implementation of the zipper leaves some properties to be desired. So we're going to fix those hopefully today, and using our newfound knowledge of zippers and how to implement them, hopefully we can get that fixed up, and that will lead us to finally being able to finish insert and implement that properly, so on and so forth. So, some stuff I have managed to do over the break was just to start cleaning things up a little bit in the repo. I managed to, let's see, yeah, just kind of clean up some of the build files and some of the configuration, things like that. I'm just going to pull those now. Fetch conversions. I think this might be a little bit out of date. And get that started. Yeah, a few commits there. Updated the golden tests with some test dependencies. Removed an unused package.yaml. Worked on some of the tests, I guess. Related to the golden tests again. Did stuff on master. Merge that back in. This is good. And what did I add in the B+Tree spec there? Also, I'm trying something new on the stream too. I'm trying to streaming at a slightly higher resolution. I noticed that sometimes the font size isn't, if you're trying to actually read the code, isn't so great. And you're not always here just to hear me rant and chat, so sorry if you're on a lower bandwidth. I tried not to bump it too much, but I just found with the font size, like upping the font size too much doesn't give me a lot of room to work with code-wise, so hopefully this is an okay compromise. But again, let me know if you're watching this on YouTube in the comments, or if you're following on the stream, let me know in the chat how it looks. So what did I do here at the B+Tree spec? Added some dependencies, looks like, to tests, yeah. Yeah, and I started splitting out the tests, I think, to use the kind of HSpec has this auto-discover thing, where it just uses some GHC trickeries so that I can discover modules, and if they're formatted a certain way, it'll pick those up and run them for you, so that adding new test suites is pretty straightforward. You don't have to do a whole lot of maintenance on that. So that's what that's all about. And what did I do here in this one? I'll remove some bits along. Remove some added some constraints on zipper. Yeah. Unzipper. Added some zipper tests. Cool. Those probably don't work though, if I remember correctly. So we'll work on this tonight. Because if there's one thing I learned, reminded myself of, when I was working on the Advent of Code challenges, obviously I wasn't going for speed, but I don't always like to just code for speed. It's one, not super fun for me. Two, I'm not terribly good at it. I end up just like going, writing a bunch of code and kind of works, and then like something's wrong with it, but I don't know what. So I'm not terribly good at the speed coding and all that kind of stuff, which is probably why I gravitate to certain things like this, maybe. I don't know. Anyway, the thing, I'm getting off track. The thing I reminded myself of is that when problems got difficult, or I started doing that, where I would just start writing the code to get the solution, thinking, I got this. I always found that I spent a lot of time tweaking things, running the solution, getting the wrong answer, and I should just chill, start with the test, start with knowing, or at least some kind of specification about what is the correct answer look like, what does it look like, what do you expect, what should you expect from this, and that ended up, when I took a step back and started doing that, the solutions came a lot more straightforwardly, and I ended up with some pretty decent code in some cases, I think. So I know I've been kind of skimping a little bit on the tests here. So I'm gonna, since we did that stuff with zippers, wrote a bunch of tests for that. I'm gonna try and do that here. So let's pull those in. Push. Pull with rebase into our branch here. And get that going. We'll just run it fast at first here and see what happens. So if you're in the house and chat tonight, say what's up. Tell me what's on your mind. What do you want to see out of the stream too? Out of Rosby? You know? Curious to know. Yeah. Okay. Yeah. There's some type errors here, so we'll get rid of those. Get this going. Reverse fish. Let's get rid of that one. Projects, maybe? Hey, Ben. Do I have any plans for formal verification? Yeah, you know, obviously I've been thinking about that a fair bit. Not only with Lean, but I also advocate a lot for the use of TLA Plus in a lot of situations, or in many situations where it seems appropriate. And I've been thinking of like doing that on stream, because I find when I mention TLA Plus, not a whole lot of people know what I'm talking about. And if they've heard about it, they haven't really used it, so they're not really sure what it's all about and how they can use it. So it might be an interesting project for us to work on. Maybe doing some verification work. And, you know, talking about specifications and why they're useful, and more the practical aspects of it rather than the theoretical ones. As we like to do on this channel, the stream. So yeah, I've been thinking about that, like either Lean or TLA Plus. So I have some ideas for that. I'm not sure where I'm going to go with it. I'm floating one past my colleague and friend Simon, who is big into Lean, is a maintainer of MathLib, and does a lot of that work. About having him come on, and maybe we could do something there. You know, another thing I'm kind of interested in is differential privacy, privacy and security in general, and knowing that your software does what you say it does, and being pretty certain about that. So I was thinking one idea I was floating around was maybe we would get Google has a differential privacy library that they use. It's open source. Maybe we could work on something in that domain and verify that those algorithms, you know, have the properties that are claimed that they have. It's kind of important these days, and it's going to be more and more important, I think, as time goes on. Data leaks aren't going to go away, and if we're not dealing with that somehow, you know, where are we going to end up in a few years? I don't know. I value reliability and maintainability a lot, security and privacy as well. And yeah, always kind of at the back of my mind. I'm like, we could do better sometimes, you know? Like, it doesn't always have to be just duct tape and glue and, oh, well, we have an error in production, we leak, we'll fix it. You know? Test. Did I put those in the zipper tests in B+Tree? I did. Okay, so the zipper identity test, which one's the one that, I think they're probably both failed, if I remember correctly. No, it's just the one. Okay. So our identity test works. That's good. And the other thing we needed to be able to do with a zipper is then we need to be able to move around it and then move back to the top and unzip the whole thing. Right, preserving any modifications we make along the way, which is, I think, what originally motivated that comment on YouTube, on that one video from a while ago. Yeah. So Differential privacy is, I guess in a nutshell, the ability for two systems to share information without leaking to the other party anything that shouldn't be leaked. Private information. An example, I think a colleague, a good friend of mine worked on a system that enabled two parties to share data sets for the purposes of building a machine learning model, for training a model. And they used some differential privacy stuff to ensure that those two parties could share that data safely, because for political reasons there would be restrictions on what kind of information you're allowed to export across borders and things like that. But in order to, University A has information about patients, a bunch of patients and something, and University C in another area has a bunch of data they want, and they want to build a machine learning model together, but they can't share that data. So the differential privacy things allows them to share that data without A or B getting access to the information that they need. So each party in return gets a model where the privacy of all the individual people in that data set is preserved, which is a pretty useful thing to have, I think. They did pretty well. So if we're going to trust those systems more and more, I think it'd be useful to have guarantees that they do what they say they do. Personally, I'm not. Now the hard part about it is that I'm not a researcher who does a lot of proofs and verification work professionally, so I'm just learning this stuff. So that's kind of why I kind of want to bring someone in who does know it really, really well to help it. And I can ask the silly questions and they can hopefully answer it for us. TLA Plus I'm a little bit more familiar with. That one I have done work with professionally, and it's pretty straightforward for me to understand. I'm pretty sure I can teach that one to most people. Okay, so moving on. What to do here? The problem with this, I think. Let's look at that code again. Now that we have tests, let's just get rid of that. Yeah, Ben. So basically the idea is that the two parties can share their data sets with the service, right? And in return, they get a model, a trained model, I guess. I'm not too up on machine learning, so forgive me if my terminology is a little off. They get a model in return that they can use with their system, and all of the private information in those data sets is preserved. So party A doesn't get to see the private information in party B's data set, and likewise on the other side as well. Okay. So there's a lot of other cases where we can use these sorts of algorithms so that we can gain analytics about how users use our systems on the internet, online, without moving those data sets around and copying those data sets around and sharing that private information. Right, and having code also that you can ship that also carries the proof that it won't leak private information is pretty cool. Pretty neat idea anyway. It's kind of pie in the sky, but it's still kind of cool. Not really sure how it would shake out in practice. That's kind of cool. Those are the kind of questions I'd like answers to. So move to top, move up, move down. Those are all good. Down. So as we recall from zippers, when we build these crumbs, we build up a list of outcomes. We have to maintain all of the state that we had at a particular node before we make the move, so that when we want to return to that point, we take that from off the stack, and we could reapply it to the current node that we're looking at in order to build the prior or parent state, at least in the case of a tree. And one thing I don't think down is doing here is that we do when we do move down is that we choose an index to move down to here. I don't really care right now. Gosh darn computers. So yeah, we choose an index here, but we don't save that in our crumb, and that index, if I recall correctly here, is used to move down to a particular child in the node. Right, in the tree. So we should probably put that in the crumb as well. Keys, and so this vector here represents the keys when we go down from a node to either another node or a leaf. And since we can't go down from a leaf to another part of the tree, then we don't need a down step for that. So we don't have to preserve any leaf type information in this crumb. I just want to call this down 2. I need this to the first argument. I think that makes it work. Down to that index. And then the rest is just the data, the preserving the information we need to preserve, but the moving from. I think that's good. I don't know if I like this unzipper function. If I look at the test, what I really want to be able to see, like from our other zipper example that worked pretty well, was our unzip function just kind of undoes wherever we are in the tree and goes all the way to the top rather than us manually moving to the top. So I'm going to fix that too. I want to be able to see this go like, I don't know if we should call it unzipper. We'll probably shadow a name if we get unzip. Call it like zip up. Or let's just leave it unzipper for now. And let's get rid of move to top. Zipper the root like this. I want to be able to write this, I think. I think I want to be able to write that. Basically, unzipper should take a zipper and wherever it is to the top. This should be this should be the same as just the root. That's better. Because move down is going to return. Let's move down and return. Well, I guess we should find out. Returns another zipper and maybe zipper because we might not be able to go down any further. Right. So we should probably remove that maybe, at least in the test. What are we going to put up for a default value though? That would fail. Not sure. Something kind of like that, I think. What I want to do is just start running these. Maybe let's compile this. Test fast, sure. Probably gonna fail because we got a hole there at least, but should. Okay, down 2. Of course, we got that error right there. Should probably fix that first. And there. And it also takes an index now, so we should put that in there. And this is an interesting point, and I think we'll fix the problem. I think the problem that was noted is that, well, we'll see in a minute, but let's just make this work first. We'll be sure of that. Let the tests do the talking so that we know we got it right. Okay, there's our hole. That's good. I don't want to put root in there. If I can just put on the phone, because I don't really care that much. It's not really, oh, it's just not a scope. Cool. Let's import that. Might be a slightly better API for our zippers. Maybe, but maybe not. Just rambling. Yeah. Okay, so we expect this to maybe this function. Okay. That's odd. I've done something a little bit not good here. Which is we could probably have an extra parentheses here. We don't really need. It goes haha. Let's put that on file watch. Cool. Okay, cool. It's all compiling now, but we got test failures, which is good. Okay, so moving down and back to the top. returns the root. We just return the leaf here. Right, so unzipper, right, is just returning whatever is currently focused on by the zipper. So at least it's going down. But unzipper, we need to fix unzipper so that it goes back to the top. You can ignore those tests for now. Let's just focus on that one. Let's use our little match here. Fast match TA. That. We need to that. Let's get rid of that entire thing. So we just focus on the zipper tests. Maybe all of them. Okay, so unzipper then. I want to make that unzip the whole thing and rebuild as we go. So we have the empty case. We just return T, we're done. We've rebuilt the whole thing. Otherwise, we have a crumb, and it's going, the only crumb we can match on right now is just down to index, order, keys, and then possibly more crumbs. In this case, we need to build a new zipper with the reconstructed T from the down 2 crumb. And then we need to call unzipper on that. So that thing there with C's. That thing there should be the this is where we need T. T could be, we need to mention T at some point, I'm sure. So we could do a node straight here from the keys and childs. Right, yes. Construct a new node, because we know it's going to be a node if we're going back up. And our node constructor, if I remember correctly, yeah, it takes an order, Ks and childs. And so we can put that, keys. But childs we have to update. Because we're going to put T back in its place in childs. Call it like child's prime. I like calling things prime. I don't know why. It's probably a terrible practice and people hate me for it. So, hate away, make a pull request, clean it up, write a style guide for the project. It's all good. But for now, child's prime. And child's prime, we need to do something, we need to update child's. Vector update function, I think, goes like this. We get a tuple of indices, which we have, index, and the value you want to put at that index. I think that's the operator, but it's not in scope. V dot whatever has. So let's just bring it in scope. So I'm just gonna shadow it. Fine. We're working with vectors here. Yeah. Okay. So what does that do for us here? Let's force a rebuild just to make sure that I actually picked it up. Did we fix it? Success! So our unzip function works, returns the root. What else do we need to be able to do, though? Well, I guess we'll figure out more as we go along. That's good. That fixes that. I like that. This means we don't need move to top. Do we need move up? Move up almost does the same thing as what we want, except it just does it in maybe. Why is that? Well, that's because we might move up to the root and try to move up again, which we can't do in the zipper, so maybe you can't move up from the root. Makes kind of some sense, maybe. But if we implement that here, that move up functionality here, then we can use... We can actually move this equation down into move up and then implement unzipper in terms of the idea of move up. Or we could just get rid of move up altogether if we're not really going to... But I think we're going to use it, probably. Because we might want to move up and then do some other thing with that node that we move up to, and then move up again, as we recall. So yeah, let's do that. Down here, put that here. Do this one. And if this works, we should be able to just get this whole zipper here. We get the maybe here, right? That's true. I think that means we could probably move this here. Can't move up anymore, that means we're at the root. And we can return just the focus, just root. Otherwise, we move up again on that node. This isn't quite right because we expected a type. No, unzipper, sorry. In terms of ourselves. That makes more sense. Still a couple of type errors here, because we're using move to top at some point. Up here. Could just call it keys. No harm in that. unzipper heading. This moves. Oh, right. We have the cases we gotta handle here, of course. So that should be a just. Yeah. It's this one here. This one here is because we don't have T as scope, because move up didn't care about it before, so let's just bring that back in. Yeah. Validated.list is redundant. Get that. Excellent. Good. Pretty sure the tests are still passing. I'm just forcing a rebuild just because I wasn't paying attention, if it was still going, or if the file watcher is not working for some reason. Ugh. Okay. So, unzipper in terms of move up, still good. I'm okay with that code. What else? Do we need all of those constraints on... Maybe? Let's see. Yeah, I don't think the file watcher is working for some reason. How disappointing. Am I not making the argument right? Oh, let's do a force rebuild. No. Just... reset the time. Try it again. Just start over. Okay. Yeah. Maybe we don't need those constraints on there, so keep them. Seems to be okay with it. Tests are okay. Right. Cool. Let's commit that. That's a good checkpoint. So modify. Refactoring zipper. Tests. Okay, next, what should we do? Move up, move down. Probably wouldn't hurt to have just a couple more tests just in case. Not too worried about it, but it never hurts, just as a sanity check. I mean, maybe it hurts to have too many unit tests. I don't know. Does it hurt your code base? Do you practice a lot of test-driven development and have, 80%, 90% coverage rules and things like that, or are you kind of light on the tests? Trust the type system a little bit more to replace some of those tests for you. Always a hot topic, perennial favorite. Many developers. Let's see. Say move. Should move. Down, up, and unzip to the root. So like combining two of our zipper operations together should, the ones that are the opposite of each other should return the same root and not affect anything. I think in the zipper stream we did this with property tests, which covered a lot of cases for us. Might want to do that too. So let's get our root here. unzipper. Move from emitter. And we're going to combine. We're going to move up after. This is where I might want to use a friendly little fish. Emitter. And we'll pass in zippered up root. Alright, okay, cool. That should be root as before. Yeah, that's disappointing that we have to manually force a reval every time. I almost never have problems with the file launcher. It might just be something to do with WSL2 or something. Okay. That seems to be good. What else? Moving up from the root. We should just return the root. Unzip to the root. I don't know. I'm not writing very good specs here. They're okay. Hopefully they're understandable. It's I think it's kind of useful to write them out as Englishy or whatever language you use as you can, so that they're communicated well. One of the things I do sometimes when I'm coming into a new code base is I look right at the tests to understand what the code should be doing and how it is expected to operate, right? And if you're not too clear on that, it can be just as... I might as well just go read the code itself. I'm kind of repeating and copy and pasting this example over and over again, though. Which can, again, make the code annoying to read. So, maybe just move up from the root. And that should be just the root. Nope. That way, please. Yes. Okay. Okay, cool. We got a test failure. Oh, I called. It evaluated undefined. Nice, because we return nothing. So we actually do expect this case. Don't we? Or no, maybe from maybe just isn't right here with just move up. Right, that's just not a good test for that. So let's just remove it from maybe there. We can't unzipper it because we need a straight zipper. That's kind of why I'm thinking unzipper might be. Maybe it needs to live in maybe just because. However, if we do just call move up right on our zippered root, it should be We can't move up from there. In which case we should probably change the documentation here. Well, that's kind of an obvious one too. I'm not sure if I even like this anymore. Blah, blah, blah. That's just testing an obvious case. Well, not terribly useful. I'm happy getting rid of that. Excuse me, I don't have my water looking today. I'm not hydrating like I should be. But we use move up in terms of the identity. Sorry, and one of our other tests on using unzippers. So we got coverage there. Okay. That's cool. So we can move up, we can move down. We could encode the modifications we want to do in our crumbs, possibly as well. How would we do that? Because moving around a tree is all fine and dandy, but really when we're implementing insert, will this do? Is this enough verbs for us to implement insert? That's the question. Or can we implement our operations or insert as into the zipper itself? What I'm thinking is, my thinking here, pardon me, is that you could put on a, like if you were doing this for a binary tree example, you could put your modifications to the tree as a crumb. So not only did you go left, did you go right? What would it matter if you wanted to put that as a crumb? So you get to a leaf node, right? And you want it, or a node, and you want to change the value of that node, and then move on to another node, like move up or down. And then when you unzip the whole thing, you want to preserve all those changes on here. So the unzip operation kind of builds the data structure from wherever you are. And then garbage collects the rest. That's no longer useful. And just trying to think of the modifications, if you would need to preserve those in the crumbs. Because if I go down, we get to the bottom, we case match on the bottom at nothing, which means we're at a leaf. Right, we have to split that leaf. I can't really trust that move up is going to do the right thing here. Exactly. So, what would that look like? In terms of a zipper operation. I don't know if I can do it split. Okay, I think I'm going to call B+Tree zipper, fix B+Tree zipper. We're going to do on insert redux, redo. So the basic case, when I go to a zipper, I'm going to just modify the data structure there itself when I get to the move node, and then when I move up, it's going to preserve the T there in terms of the childs at that index. That's what it means to me. I'm trying to zip it in. Okay. That's a lot of other code here. Okay, so we have kind of started. I did kind of start doing that. This merge operation. Job. Yeah, okay. Yeah. Well, what should we do? Tests. Okay, so let's stop running that one. Right, when in doubt, when you don't know what to do, my wayward son, just start with a test. Write it as a spec. What do you think your program should do? And does it do it or not? I don't know. Currently, it doesn't do something I expect. Which is kind of expected. So insert should split a root. Leaf into. Okay. So that means this one works. Which is good. So something about what we're doing is okay so far. This might not be though. I think that's what's failing right now. Only one. Okay, so I'm gonna get my matcher going again, so we can ignore the other tests as we did before. Test fast file HTA. Pasting into the Windows terminal is kind of odd. It's kind of Unixy. Like most of my key muscle memory works on it. Not all of it. I'll skip that one. Look right there. Kind of made specific to that one test, but that's okay. That's kind of what I want right now anyway. Okay. So what do we got here? I expected a node with split leaf. Is this correct? Insert B and 3 into the node of order 3. So in order 3, leaf, I think this is constructed properly. We're allowed to have 3 elements in the leaf. A, B, C, and D. Okay, so when we split it, I think we should get a node with A and B. C should be the key, and then CD should be the other child. Right. So we have that here, a node whose keys is just C. We should have 2 leaves. Let's just make this kind of one window so we can see that. Ish. Put the dollar sign over here. Phase this out a bit. There. That's about right. There are 2 leaves, both of order 3, A, B, and C, D with the appropriate values for each. Yeah. Okay, but we're just getting a leaf. Okay, so something about our split. When we unzip this, we're not doing really anything, it looks like. Insert with. So when we're using insert, we zip up the tree we're given in our zipper. I'll insert with these key and value on that zipper. We're supposed to traverse, but not traverse, but like zip through our tree and insert and split things and merge as it needs to, and like the algorithm describes. And then unzipper should unzip the tree back to the root and give us back our root B-tree. Okay. So the type of that and the shape of that makes sense to me. Looks like we pull apart the zipper here. So it looks like we're only focusing on the leaf node here. We've left the other cases undefined at the moment. Let's see, so first things first. If the size of the values in the leaf is less than or equal to our order, so pulling out the integer part, I guess. And we smart constructors for the order, then we construct a leaf, and we just insert that key value. We know that branch works because that one test does cover this part. So it must be in the other ones here. Okay. In that case, map span antitone. Splitting the keys and values, I guess, is into 2 maps. So we get 2 leaves. What are we actually getting? It looks like we're only getting one of them. And it's the left one. But with C on the end. So that's not quite right. So I guess span is inclusive on what it splits. Oh, I'd expect if it was A, B, and C that it would split to A, B, and C. Something's going on there. And then our merge up operation is not doing what we want, clearly. So Ben, or anybody else who's watching, how's the resolution on this? Can you see the text just fine? I was talking about that at the beginning of the stream, and just kind of curious if it's working for you. Cool. Thank you for checking. Okie doke. Yeah, so let's see. Let's see if we can get spin and tone to work the way I want it to. So we're trying to insert with B in this text, aren't we? Which would make sense. Or it be less than. Just put this thing. Okay, maybe it should be less than equal. We want C to be on the right leaf. And for that value, C to move up into the node. Let's see what happens. Not super sure. I think that might be okay. Might do what we want. Should be just, at least at this stage, get AB. If we're just getting the left. And not merging up properly. Maybe because I'm not doing... Well, maybe span into tone is just fine. Let's see, what's the other part? So merge up, we did construct a new node. Singleton key K. So K, in this case, what is that? How come I'm getting a leaf? That's interesting. Maybe we are just hitting this branch. Let me just double check that quickly. So order 3 already has ABC in it. Okay. Yeah, no, I still expect the leaf on the left to be this, but if we are hitting that branch, and this is the, we're just returning this again. One way I could probably tell is if we bring in our friend debug trace. Just as a sanity check here, I think that's probably what's going on here, so I just want to be sure. I kind of expected that change to be to time to do something. So let's just trace this out here. Possibly on a plus node? Are we... Our file launcher still probably isn't working. Which is too bad, but what can you do? Not here to debug WSL Linux. I don't see my Diva trace anywhere here. That could just be because the test runner is swallowing I/O. I'll try to be helpful, but let's put a trace on the other branch and see if we're heading down that one. Okay with the car, but we don't know that. Yeah, we don't know that we can show it, so let's just add that back in there temporarily. Okay, cool. Nothing. Boo. Okay, clearly that's no good. It looks like we are not gonna be able to do that from within the test suite. The only other way... Oh, hang on, let's try one more thing. I'll put that back in there. Let's do it in the REPL. So just taking from our spec, example root. And test insert with our key D from our example, 3, and zipper. Okay. What? Does trace, maybe trace doesn't work here? Let's see why not, but I see never really know, maybe? Ah, okay. I guess it doesn't. Alright, good to know. Yeah, so we are getting to that branch, and for some reason it's returning just the B leaf. So merge up. Is not doing what we think it should be doing. Right. So K in this case is actually D. So in that case, yeah, C would be less than D. And so it would go if the left is inclusive to the left side, which would be no good. No bueno. Oh. not inclusive, then it should be on the right side. So, unfortunately, it looks like that one is a no-show instance for map like this. Oh, it doesn't show on V. Okay, sure. Oh, and then insert data to one. Okay. Yeah, okay. So right is empty. Right, so we don't want to necessarily split on anything less than 2. I think that's wrong. We need to actually split on a midpoint. Because our list of keys might actually be longer than 3. Okay. In the case of ABC, the midpoint would actually be C after we add D into the mix. I'm preferring the right-hand side if we get an EVA split. So we need a better algorithm for that part. And then, hopefully we gotta fix merge up here to properly construct the node that we want to return. Actually, in the case we're at the B leaf already, we know it's going to be a node. Oh yeah, but we might need to also split that node and so on and so forth up to the root. So I think that kind of makes sense to merge up on that node as well. Okay, so how to implement that? We only got about half an hour left. So let's go for it. So we could do like a binary search. Or no, just a plain old midpoint. Index, since we do have a vector, we'll create like a, well, we need the vector of the things with the thing we're trying to insert. It's got to be sorted. Right, because all the leaves, eventually, all leaves have to preserve the sorting property of our data structure. So if we construct the vector with what we're trying to insert and find the midpoint of that new one, we would get, in our example, we would get C, but we would get the middle point. And then we can construct the split of the two vectors from that into the children that we're going to use in the node that we're building here and merging. And I think we might even be able to do that without any extra intermediate copies as well, if I'm not mistaken. The vector API. Okay. So first things first. let's get the keys. Oh, no keys, potentially no keys. That's going to be... Here's the thing we learned through doing this is that vector doesn't have a sort for some reason. Maybe there's a package for it and I'd really like to see it, but like a nice in-place sort. Because we're going to have to place key k in the sort order in order to preserve our sorted property when we split this in two. So the way I've been doing is kind of like that ugly hack where I just use the sort on lists and then the vector constructor from that. Ugh, terrible, I know. Gross, blech, barf. But we should probably research that at some point. But let's just make it work. And we'll make it fast. It'll be okay, hopefully. In that case, what do we have here? The no keys. I'm going to get the keys from the map. Keys, which I think does return a list. Keys, I think, is the map. Right, and we want to sort because okay, we're trying to insert onto that list. I really want sort. What's an ORD an ORD instance on those? Oh, maybe it's in data.list. Although it should be fairly. Okay. So we sort that. I want to do something with it. We want to construct it into a vector so we can get the indexes. Let's look at my camera slip there a little bit. Pardon-moi. Adjusting things behind the scenes. Lead up from list. Okay. So we have that, and we want the midpoint. It's going to be the length of node keys rounded up. I wonder if we can get a rounded. Normally. Round down, but if we use the right division here, it might sort out. So let's take the length, v.length, node keys, and what we're going to do with that. We're going to divide it with that. Now that takes an integral back into the orange. Wait, what I'm thinking. Really, let's like seal some. It's good enough. And then the middle key, or the key prime of the node. This will be like all keys. And then the node key will be thing at that index. Now we just have the maybe, so there could be a case where we have to deal with that. Yeah. The only thing I think the mid formula here is not so great. It's just, I know there's type errors. Because if we get the length of 4 div 2, we're going to get an index of 2. Oh, actually, that works out just fine. What happens if we get 5 div 2? We should get 2 again, or 3? 2 again. It's only if we get 6 div 2 that we'll get to 3. I think that makes sense, right? We want it -1. No, we don't want it, because if we have order 4, we 0, 1, 2, 3, and 2 is the one we want to actually split on. And we want that to be the key as well. So yeah, I think that's good. 5, 2 would be 0, 2 would be as well. This would be the exact middle, and these would be 2. So we move this one up. But then we want these 3 moved over to the side. Live long and prosper, and then 6, yeah. Makes sense. Okay, cool. So that's okay, so we get the node key from there, and then we know that we can split map. Yeah. And 2. Although we will not only need to split the keys, we also need to split the values that go with those keys, which is why we used expand into tone, but even though it wasn't quite correct. So I wonder if there's a way for us to insert into the map, and that the map preserves order of the keys for us. I think it does. And in that case, we just need to insert our key and value into that map. And then we can use split into tone again, I think, to do what we want. That's probably what I was originally going for. So this might have all just been a diversion. And a roundabout way of getting back to where we were, only proper. That's okay. We learned some things along the way. I want a new window. So we can look at that together. Map. I think that's the one we're using here in this package. Yep. KV type. think that's why split antitone works. Fun times. Rediscovering your code you haven't touched in a few months, right? Split, yeah. So you want an ORed case. So there is an order to the keys on the thing. So if we just insert that key value pair into there, then we can split the children right off there. Then we just need to make sure that we pull out that middle key. That's the only thing we need to be able to do so that we can construct the node. Super duper. Ah, there it is. Span. And span into. Not necessarily what we want. Twilight falls on empty streets. Yeah, I think we want, if we can pull out the key at that right thing at our particular index, be able to do it. So let's do that. Where was I? I'm losing touch with everything. I think we were in there. Yep. So we have the key that we want. Or at least we might have the key we want. So I don't particularly like this fact that we have to like handle this possibly empty case, even though we know in this branch it technically won't happen. Kind of annoying, but we take the good with it. We gotta take some good, I guess. So we got the key. The left and the right again we can get by inserting the K and the V that we have into the V's, and then splitting that. Well, node key, but node key is maybe, so that's kind of annoying. I'm tempted to be kind of gross and polish that out. I wonder what the clean, proper way to do it would be here. Because we just need to give that value here. Could like maybe get nasty here, like case match on it to get it out. Which is kind of gross because if we go to the nothing case, then like I don't know. What do we put there? Right. Otherwise, we have the node key that we actually want. And everything else. Then we got another, proceed to another let line. Like, this is so gross. I do not like it. One bit, Sam, I am. Because then we can end split on NK. Or sorry, it's not. Unlimited variables. Like just so let's see. Still have a couple of type errors, bracket, blah blah blah. Oh, we're removing some trace we left behind. At least, like, okay, so this type checks me. I don't know. I still don't know if it's right though. I suspect it's not, but let's see. Oh, let me know how it tests. Yeah, good. Okay. Well, it failed, like it should, because it's not done yet. So we're getting leaf still. We're still getting A, B, and C. I'm still kind of like, even in a correct solution, our semi-correct solution now, A and B, or C and D, but not A, B, and C in a leaf node, which makes me think this didn't do anything, which would be very disappointing. Arrgh. Okay. Why, like, reattaching C at any point? Left, right. Let me get trace back in here and just see what NK is. I expect it to be C. However, it might not be. So we can't do it in the let binding itself, but we do it down here. Okay, happy little friend. Good, let's go back to our REPL. Bring our example back. And try our insert with D there again. Actually, NK is A. Not what I expected at all. Okay. Oh,
Fires rise from burning shells of what once used to be. On cobalt streets, temptation sparks.
No, NK should not be that. So we totally got something up here. Good. So we get the N keys from these. What do we get for? I guess that means mid must be 0. That's all keys. Okay, so all keys is A, B, C, D. Well, it might be that mid is wrong, according to that. Okay. Yeah, okay, mid is 0, and we kind of expected mid to be 2. Let's not be silly, oh, yep. Might be that this is wrong in the wrong order, of course. That's probably my issue. Killing me. Okay. No. There, mid is 2, that's proper. Okay, we're still getting the weird B leaf, the wrong thing. Or the thing we don't want, anyway. But that's something. So NK should be C. That's our no key. Okay, so if if NK is C and split does what I thought it did, which hopefully it's not increasing. So smaller than K. And keys in map 2 are larger than K. Okay, any key equal to K is found in neither map 1 nor map 2, which isn't quite what's going on here, it doesn't look like. Yeah, that doesn't seem to be true. Hey, Swarm Collective, how's it going? Doing some Haskell. Working on the databases. And just kind of being somewhat surprised that map.split isn't quite doing what the documentation says it does, or we're doing something wrong. Right, so that's kind of interesting. So if I import that, I qualify maybe. Right, I create test map equals map.funlist. There we go. That. Let's do it in reverse. Let's use integers as our keys. Chars. B. And 3. C. Let's say 4. D. Oh, I already have that. Oh, great. Okay. Yeah, we're building a database. We're building a KeyValue data store. So not like a full-on RDBMS or anything like that, but, you know, something non-trivial, but not too huge. I'm just trying to figure out why on earth map.split says that if there's a key that equals to the value we want to split on, it shouldn't appear in the two submaps. But in this equation on line 54, that appears not to be the case. I'm just doing a little test here. Okay, and if we do m.split on 3, with test map, we should get back a tuple with 1 and 2 and another map with 4. That's correct. Okay, now what I'm seeing happen, maybe I'm just going bonkers and losing my mind. Okay, is if we do from list here and we use chars. Now maybe there's a reasonable explanation for this. This is kind of what we have in our test example. For D, and if I split on C and test map 2, I expect to get a tuple of 2 maps. The first one should have keys A and B, and the second one should just have the key D. Okay, that's true here. That's good. So, something weird. I must be doing something weird. Let's show that. Weird. Okay, then why is it doing that? Left is... left. And we should see, or at least I want to see, a map with just A and B in it. Given our test example root. So if we insert with, oh no, you know what, it might be me. I'm just realizing it now. Let's put it in this. Okay. What have I done here with this repo? I've gotten myself to a bad state is what I've done. Just kill it. Fresh. Fresh repo. Thank you. Okay. So our test root here. Place that in. Okay. Yeah, no. I should be able to, yeah, okay. Well, I should be able to see D3 with a zippered root. Okay, so NK is C, that's right. And from list is AB. Okay, cool. That's what I expect left to be. And then right should be C and D. Oops. Or just D. That's fine. Just D is okay. No. D isn't okay. We actually do want to keep C in there. But that is... okay, that's good. Okay, so we don't exactly want split, because then we have to reinsert C, and then C's value from thing. So let's just remember split antitone, because I think that's originally what we had there. We divide when it stops holding. So we're responsible that for all keys J and K in the map, J is less than K, implies that some P of J. I guess that's the predicate. Yeah, the predicate of J is greater than or equal to the predicate of K. And the reason why I want that is hopefully because less partition. The partition might be closer to what we're looking. Basically, I don't want to lose the key C and its value in the newly constructed lists that we're going to put into the node constructor. So, partition looks promising. Serves contains all the evidence to satisfy predicates. We want less than C, so like AB. And everything else. So the hopefully right will have C. Okay, let's try that. Let's get rid of this debug trace because we're okay once we get to this part. Here, we just don't want M split. We want partition. And that has to be a predicate, which needs to be less than or equal to our NK, our node key. Type error here, though. Oops. What am I doing? I think we got something flipped around here by accident. Partition takes our predicate as a placed argument. That's what I expect. And then a map. Okay, yeah. Right. Match type V with K. Oh, because it doesn't, maybe it's because I'm using NK here that it doesn't quite know that that's the same thing, maybe? What do you think type of NK is? Oh, okay, that's why. Partition's on the value. We want a partition on the key. Sorry, that's the wrong one. We don't really care about the value, we just want partition on the key. So, I guess we have to, like, use partition with key. Okay. Try that. Oof. Don't care about the value. This key. Other key. So that's not okay, cool. That's better. Let's check it out. And we'll get back to running the tests again. Once I'm good at this. No! Curse you. Just double, triple check here. Okay. Almost. Left is... What is left? Showing that. Right is... Go to the right. Tell me I've split things properly by now. Come on. No, we're still getting C. Oh, maybe because my relation is not quite right. That would make sense. Okay, that's better. That's what I. Okay, cool. We're still getting that leaf with A, B, and C though, but okay. Left is A and B, and right as C and D. Okay, so at least that part's correct up to that point. Oh, we're almost there. Okay, so what's the problem here now is no longer are... We have C, that's right. NK is correct. Left, right. We're good there. Which means we should be able to construct a node with the appropriate children. The correct key. This should be NK. And left and right should all be fine. And then we want to merge this newly constructed node up to the next level in our tree, potentially. So, at least on the surface, that formula still looks like it should make sense. Let's see if our test agrees. It looks like it's still just returning the leaf, though, but we'll see. I think it might pass. No, it didn't. Not even close. Yeah, okay, cool. Well, that's fine. That just means... What does that mean? We're doing something funky. Merge up. That's all. And then another thing I'm a little bit concerned about is that this test is testing too much. Like, I'm doing quite a lot of work. We could probably scrunch down a little bit and just come up with a case for merge up. Let's see what's up with that. I think it's either merge up or merge. We have a mistake in somewhere, and it's bubbling up to our test on it, so here. So, unfortunately though, kind of out of time, so I'm going to check in what we have here. And push up what we've managed to do tonight. Cool. So what did we do in this change, really? We started implementing insert in terms of our fixed zipper and handling the started adding tests, really. Just kind of fixing things up. I don't know what this blank line here. Blank. Random blank lines. Never. Maybe that was intentional, I don't know, but... I'm not quite satisfied because I want to remove the debug trace first, so... Just cancel this for a second. Yeah, so we added a couple tests. I'm getting it going. So, thanks for the tips, Storm Collective. Yeah, I probably could. Probably could clean that code up for sure. And avoid that lambda. I was kind of thinking there's probably a way I could avoid it as well. However, we might as well do that while we're just cleaning up that file because it's not quite ready. checked in with debug trace still coming in there. Yeah, switching. That's the user first position. Why? Something like, yeah. There's two parameters there. That's why it's. Yeah. Unfortunately, two parameters. So if there might be maybe there's a function to ignore an unused parameter or something, some kind of combinator. It's not the worst. But I wanted to get rid of that tuple, that thing. At least debug trace, so we can leave that in. Let's just take a look at the diff now. Let's do that. Refresh. Slow. Oh, okay, I gotta merge those. Bleh. It's on stage. There we go. Review. I think it looks pretty clean now. Just data list. That's okay. A couple of tests. Happy with that. Check it in. And I don't know. We need one of our tests to pass. It's still a work in progress. Not too bad. It's starting to feel a little bit like things are going on a course now, so hopefully once we break down and start adding more proper tests for insert and the other tree operations, we'll nail that one down. So. And then we can start working on the storage backend. It's going to be the cool part. At least the part I want to investigate. So no worries, Swarm Collective. Thanks for the tips. I always like getting, chat coming in and you guys and friends helping me out and offering those suggestions. So please keep them coming. And, be safe out there. Good luck with everything. And may your monads always be free. Your types always check. Have fun hacking Haskell. Tell me about your projects sometimes. Follow me on Twitter. I'm also, if you might have noticed, trying to broaden my reach, bring in a few more people interested in Haskell. So if you give us a follow here, that would be great. If you're on YouTube, watching there, give me a subscribe, whatever. And that really helps make sure that I'm on the right track. And yeah, I'll see you around. Take it easy out there.